So that's exciting.
Yeah.
All right. Welcome, everybody. Hugo Bowne-Anderson here. I am so excited to be here today with Zack Newman, a research scientist at Chainguard, to talk about supply chain security in machine learning. And we're going to get started in a couple of minutes. It's great to see already nearly 30 people here watching. So if you're just joining, it'd be great if you could introduce yourself in the chat on YouTube and let us know who you are, where you're calling in from. If you're interested, what type of work you do and where you work, because we'd love to be able to tailor the conversation to the people here today. Yeah, so introduce yourself in the chat and we'll get started in a couple of minutes, everyone. Hi, everyone. It's Hugo Bowne-Anderson here from Outerbounds. I'm super excited here to be here today to chat with Zack Newman from Chainguard about supply chain security in machine learning. We'll get started in a minute or two, and I'd love it if you could introduce yourself in the chat. Let us know where you're watching from and what your interest in machine learning and supply chain security are and what you do for a living, those types of things. It'd be exciting to know who we have in the digital room today. Oh, cool. Hey, Rohit. We have Rohit here. I hope I pronounced your name correctly. If not, I hope I got it close. Rohit is a data scientist with a background in theoretical physics. Looking forward to this chat, as are we. Thank you. And we have Jordan, who's a DevOps engineer based in LA, interested in various aspects of MLOps. Fantastic. Great to have you here, Jordan. Oh, Rohit, that's great. Rohit just wrote, I pronounced your name correctly, and you've taken some of my courses on DataCap. That's fantastic. Well, I hope you found them valuable. All right, we're going to get started in 1 minute, everybody. So if you'd introduce yourself in the chat, that'd be great. We have Lillian, who's a grad student majoring in computer science, who's worked for 5 years as a backend programmer. Fantastic. And we have Ian, who's based in Austin, Texas, working in the e-commerce sector. Fantastic. And actually, so I'm in the US at the moment and was in Austin last month to present a tutorial at SciPy. And I hope it's cooled down since then because it got up to 120 or something, 115 when I was there. Look, I'm so excited for this chat that I would love to get started. So Zack, why don't we turn our cameras on and jump in?
That sounds great to me.
Hey, Zack, great to see you.
Hello, I am so excited to be here.
It's great to have you here. And so, as I said, everyone, if you introduce yourself in the chat, that'd be great. I'm going to introduce you, Zack, and correct me if I get anything wrong. But Zack's a research scientist at Chainguard, where he builds software to make the software supply chain secure by default. After 4 years as a software engineer and tech lead on the Google Cloud SDK, Zack moved to MIT CSAIL to research authenticated data structures and Tor network performance. And now at Chainguard, you're pursuing your passions for developer tooling, supply chain security, and applied cryptography.
Nailed it.
Yeah. And this is so fun because we work like seemingly on different types of things, but when we started chatting, we recognized that the philosophy behind how you think about software, and how you think about security in software and supply chain security, and how we think about machine learning pipelines and building productionized machine learning software. There are lots of synchronicities there.
Yeah, I agree 100%. And I just want to give a brief warning ahead of our talk that I am relatively a dilettante when it comes to kind of the MLOps space. So my perspective here is largely going to be taking observations from sort of application-based software supply chain security and talking about how, in my mind, they are going to apply to sort of the MLOps space. And I think there's a really, really natural fit. I think everything about how Outerbounds approaches sort of ML operations aligns with how we sort of approach software supply chain security. So super excited to talk about some of those commonalities here.
Well, as am I, and thank you for being transparent about that. And, you know, I have a comment that's a bit tongue-in-cheek, but I would argue that the MLOps space is full of dilettantes. And that we're attempting to figure out, you know, what this space actually is, what the stack looks like. And in particular, and this is actually maybe a nice way to start this conversation. You know, my background's in research science. Metaflow was originally developed at Netflix. And one of the reasons I joined is because Metaflow and me and a lot of people in the space have this joint goal of building tools for scientists who aren't software engineers, right? So that scientists can actually build production grade software. People who are comfortable with science experimentation, working in notebooks, these types of things, but require access to, for example, Kubernetes clusters and the full stack of machine learning infrastructure, where they want to model things, but they need to access the data layer, the compute layer, the orchestration layer, versioning, all of these types of things. And we want to make sure that scientists can write their scientific code, but have it productionizable as quickly as possible. So one way to think about that, as you know, but this is for the audience, is so the code you would write locally, as few changes as possible to get that to production and back, to tighten this iterative loop between prototype and production.
Yeah, and I think the sort of relative newness of all of the tooling in this space points to a really tremendous opportunity here, where we can invest in the tooling itself to sort of make it do the right thing by default and make the right way the easy way. And I think for security in particular, this is extremely important. The right burden, in my mind, on sort of the average user of software tooling, be it tooling to help deploy applications to production, to deploy machine learning workloads to production, the security burden we should place on them is approximately zero. Yeah. Right? And the tooling should just work and just do the right thing by default. This comes, of course, with a real burden on the tool authors themselves, right? They have to do a bunch of work, not just to make it possible to do the right thing, but to make it really hard to do the wrong thing. But I think we do have a tremendous opportunity here. That's kind of my philosophy when it comes to, traditional the application space and supply chain security. And I think it can be the exact same philosophy in machine learning as well.
Amazing. And so what I'm hearing there, and something we'll jump into, is that this is a question of design, right? In a lot of respects, and this is something that we wrote about in our joint blog post, which I'll share in the chat. But I've been a bad host. I got so excited and jumped in before just saying a few introductory things as well. So once again, welcome everyone. Please introduce yourself in the chat. We'll be chatting for until the hour, and we're also going to have an AMA, and Ask Me Anything, on Slack afterwards. So I'm posting a link to our Slack channel, slack.outerbounds.co, our community Slack. If there's a channel called AMA Guests, so please come and join us there, but ask questions throughout and we'll try to integrate them into the discussion. And anything we don't get to, we can chat about on Slack. On top of that, if you find these types of chats interesting, please do like and subscribe and share with friends. That's how we spread the word far and wide. If I didn't introduce Outerbounds, I'd probably have to fire myself. So I'd just like to tell you a bit about what we do. I mean, you've got a sense already, but we work on infrastructure and productivity tools for data scientists that allow them to focus on building models and doing science while having easy access to all the infrastructural layers, such as compute, orchestration, versioning. We're doing this mostly through open source Metaflow, but we also have a platform which we'd love for you to check out. So definitely go to outerbounds.com and check it out. On top of that, if you're interested in this type of open source software, I'm going to put a link to our GitHub repository, the Metaflow GitHub repository. So do check that out. And if you find it interesting, give it a star as well. And I think by way of introduction, that's pretty much it. I am actually going to also share in the chat our joint blog post, which has a lot of the ideas that we're talking around today. And we've already got a really interesting comment by Jordan Schwartz, which I think maybe it's a nice way to open the conversation. Jordan wrote, "Secure by default hasn't always been a design choice."
Yeah, no, that's an extremely important point to make. And I think it's really interesting to watch sort of the evolution of all components of the security space, from, kind of the early days of computing, 60s, 70s, where the biggest worry you had is that, some prankster would be in your building physically before things were all networked together. And malware tended to be actually quite innocuous. It would play a silly message or something like that. And to watch that change, I would say the low point for all of this was probably the 1990s, because we had things on the network, but hadn't thought through at all how to make that secure. And so you had, passwords getting sent over unencrypted HTTP connections. You had people exposing unencrypted telnet ports and so if you just sat somewhere on a network with a box that was pulling packets, you would learn a heck of a lot that no one wanted you to learn. And so from there, right, like in that environment, I think was really the first attempt to move towards a more secure world. But it happened in a way that I think now is somewhat dated. And it really put the onus on individuals. And so this is when we see kind of the rise of PGP and, key signing parties. And, if you want to have secure communications with someone, you have to physically meet up with them in person and, pull out, I don't know, a note card and, with your key printed on it and type some commands in a laptop. And frankly, this was a high enough burden on security experts, let alone the average person.
Yeah.
And so I think we've seen since then, there's an entire, academic subfield called usable security, which basically asks, not only can we design a system that's theoretically secure, but can we design a system that's secure as used by actual people, which is really the question we want to be answering, right? And you see all sorts of examples of this. Really critical passwords like written in clear text on a Post-it note stuck to the monitor or that sort of thing. And so the usability aspect, I think, has been recognized in the academic space, in the industry space over the last really 20, 25 years as something that's just as important as the theoretical guarantees of the system if everyone's using it right. And so we're starting to see really an emphasis on design. And so we've had a lot of victories here. For instance, in the web, when you're browsing to a website, almost all of the time, that's going to be running, HTTPS, right? You have an encrypted connection to that website. You're confident because of the web public key infrastructure that, when I connect to example.com, in fact, I am connecting to example.com and not some meddler in the middle. And we've been able to do that in a way where the average person has no idea, right? All that they know is that, they used to have to really, really worry about connecting to their bank from the coffee shop Wi-Fi. And now they don't anymore. And that's kind of magic, right? And that's the level of magic I think we should strive for. So I'm glad to have this conversation with you all because you seem interested. But this is not a conversation that scales to every data scientist and ML engineer who doesn't really care about security. And we want to keep it that way.
Yeah, absolutely. And so I do want to dive in and talk about supply chain security and machine learning. But I'm wondering if first you could just give us a brief, before diving into ML, give us a brief kind of high level idea of what supply chain security in software actually means.
Yeah, no, that's a great question. And I think I'll warn you, supply chain security is one of these terms that's so broad as to be almost meaningless. But I think we can sort of sketch around the contours of what we mean when we say this in a way that I think will illustrate what we're concerned about today. So I think of supply chain security as constituting all of the threats to your workloads that are running in production or running, in development that have access to important data. All of those threats that you didn't introduce yourself. So most of the software that people are running by lines of code, like the vast majority, 99+%, is not software that they've written, right? The Linux kernel itself, millions and millions of lines of code. If your app is that big, you're probably at a really huge company. And even then, your app is that big probably because you depend on a number of open source libraries, maybe vendor provided code, and so on. And so I think of supply chain security as basically meaning all the threats that come from code that you didn't write yourself. So I didn't have a buffer overflow, someone upstream of me did. And this is a really, really broad definition. It includes things like I'm running a version of Nginx that has a known vulnerability in it. I put that on the internet and boom, now an attacker has compromised the node that's running Nginx, and from there can get into all sorts of other things. But it also includes deliberate attacks. So I depend on an open source library and the maintainer pushes a new update, and surprise, instead of it being a library to pad out my strings so that they're nice and right aligned, it now is a Bitcoin miner. And everything in between. So the archetypal attack in this space, the one that really got people buzzing, is the Sunburst attack on a company called SolarWinds. So SolarWinds is selling software to monitor networks, to governments, to big enterprises, and their build system got compromised. So they had a software factory where they had all of their developer source. It went through their kind of build system and wound up in a nice little package with a bow on it that they then turned around and shipped to customers for customers to run. And so attackers compromised the build system itself. And they basically said, hey, while you're compiling this source, please also insert this backdoor. And then now this is a supply chain attack in two ways, right? It's an attack on the supply chain of the software itself, the SolarWinds software itself, because it had to do with the build. It didn't have to do with a vulnerability in the software that was introduced by their developers. It had to do with the build itself. And it's also a supply chain attack in that SolarWinds is in the supply chain of a number of other organizations. And so by compromising the central point, the attackers were able to get out into really a lot of like US federal government, like there's a lot of data leaks that happen because of this. And so these are kind of the flavors of what they mean. And so there's not one type of attack, right? Like all of these attacks are slightly different, but what they have in common is they have to do with not your software, but the software you depend on, which unfortunately is most of the software. Or unfortunately for security, it's great for development, right? Nobody would be able to move nearly as fast as they were if they had to write the equivalent of PyTorch from scratch every time they wanted to, or let alone like, Jupyter write from scratch every time they wanted to do a quick little excursion on a notebook. But it does come with kind of this risk. And I think that's finally catching up to us. We had a big, party for the last decade or two where we were using all this open source software, and finally, it's starting to catch up to us, and we're having to worry about the security risks we're introducing.
Yeah, thank you for that wonderful introduction. I think we definitely have a strong sense of the types of threats and how security can help us navigate those. I'm just wondering, can you say a bit more about, I've got a sense of what the supply chain is in terms of all the, open source and otherwise software that one uses, but is there anything more to think about with respect to what supply chain actually is?
Yeah, I mean, I think it includes basically all of the steps before you're deploying to prod. And that's actually mind-bogglingly complicated, right? Because that means you have to worry about, your build system. You have to worry about the compiler version that's running on that build system. You have to worry about the compiler that compiled to that compiler, and so on. And you have to worry about, all of the open source software you are dependent on. You have to worry about the distribution step. So if you're using PyPI to pull your dependencies, how do you know PyPI is serving you the right thing? And we can get into some of the efforts that are happening on repositories themselves to improve the state of the art here. But these are kind of, yes, it's basically everything that like any system or person that touched some of the software that you're running before you run it, or touched the software that touched that software, which if you expand it out kind of recursively, really takes you back, to like decades and decades and decades before you can finally trace it. And of course, that's almost, I mean, it's basically, I'll say it, impossible to deal with at that scale. And so we sort of have to draw the line somewhere pretty reasonable. And we tend to do this by saying, okay, we're worried about direct dependencies. We're worried about the distribution of those dependencies. We're worried about the build of your application itself. And then everything kind of recursively after that, we'll get to it, once we've done a good job on those first several aspects.
Great. So I'm really glad you mentioned PyPI. I also, and something we'll get to is, especially in the data science and machine learning space, what happens if you're getting data from a variety of places, or in formats such as Pickle, which may not be secure by default. Which brings me to my next question. I suppose my question is, so we know now we have a strong sense of what supply chain security and software looks like. What happens? What changes when we're talking now about supply chain security in machine learning?
Yeah,
if anything.
I think in some sense nothing changes. Just as in some sense MLOps is really no different from DevOps writ large, right? But actually a lot does. Because the types of software you're running, the types of workload change, right? And so from the MLOps analogy, like Kubernetes from the ground up wasn't really built to handle batch workloads, but that's what a training job is. And so, I think by now we've sort of got satisfying, ways to fit that into the Kubernetes universe. But before we didn't, right? It was all kind of hacks. And so I think it's exactly the same, where in principle, nothing changes about supply chain risks. You have inputs that are coming together. You're building some, you're getting handed some from external. You have to worry about where they're coming from. You have to worry about what they're doing when you're loading them. And eventually you deploy something to prod, or you run a training job that has access to sensitive data, and you have to worry about the consequences there. But in practice, there are a bunch of differences. And so the ones that come to mind are things like, exactly. What are the workloads? What are the inputs to the workload, right? And that's often, data, right? And that's something that's very often not an input to a software or application build job. It could be, right? And in some sense, data and source code are kind of the same thing, but in another sense, they're very different and need to be managed and handled totally separately. Other differences include just the prevalence of, kind of cross-language boundary libraries, right? I don't know a whole lot of people running their, Go microservices that are calling out into Fortran, but that's what everyone running NumPy does. And so though that stack, getting that sort of, BLAS and all of that onto a machine, there's a lot of more avenues for things to go wrong. The other thing too that I'll point out is, everyone always wants the latest features when they're developing an application, but I think data scientists really always want the latest features when they're running, a training job. And that's because, the pace of the field is moving so fast. We're getting new algorithms, new models, new, optimizers every day, better support for GPUs to speed things up. GPUs are another thing that we see a lot more in the ML space than in the traditional application space. But people really want things on the bleeding edge, and that comes with its own risks, which I'm pretty sure come back to later.
I'm excited to, yeah. Great. Thank you for setting the scene more there with respect to machine learning and data science. And I like the analogy with respect to MLOps and DevOps. And I do agree, in principle, perhaps nothing changes, but a huge amount does change. And Ville and so Ville Toulos, who is the CEO of Outerbounds and develops Metaflow, and with a bunch of his wonderful colleagues, started Metaflow at Netflix in 2017 and open source in 2019. Ville and I actually wrote an essay called MLOps versus DevOps, why data actually makes it different. So I'm going to share that, and that's in VentureBeat. So I've shared that there. And one of the things we point out there is that when you introduce, the entropy of the real world into software systems, a huge amount changes in terms of kind of the stack you need to interact with as well. On top of that, the nature of the skill sets of the quote unquote engineers involved. We no longer have engineers building software, we have scientists building software, right? So the nature and experimental nature of what's happening changes incredibly. So definitely check that out. So we've just got a couple of questions. Someone says, great conversation, need to jump on another call. Thanks, that's great. And Prem Raj has asked, will the recording of this be available afterwards? And yes, this will stay on YouTube. Lawrence Freeman actually has a question. So supply chain also includes external human threats to LLMs, for example, via poisoning.
Yeah, so I think poisoning is exactly something that we would consider a supply chain threat. And now you're starting to see why I'm saying maybe the term supply chain security is so broad as to be almost meaningless, because it doesn't cover pretty much everything. But I think the same classes of mitigations are going to apply everywhere. And so poisoning, for those who aren't familiar, refers generally to taking a model or a trained model and manipulating it in some way where it's going to do something unexpected or bad on particular inputs. And so the most famous example, I think, is a work called Poison GPT, where some researchers took one of these GPT models and they taught it a lie, basically one specific fact about, I think it was maybe like, what's the capital of France? And it would say Des Moines or something like that. And they were able to do this with really surgical precision, right? The rest of the time, unless you sort of stumbled into asking the really backdoored question, the model behaved exactly as it would have it was undetectable unless you kind of fell into the trap. And so this I view as a supply chain attack because for the consumer of that model, right, that model is part of their supply chain. Yep. And so if, for instance, they thought they were getting something, fresh from, one of these companies that's training large language models directly, and in fact, on the way, from that company to them, it had been tampered with by an attacker, that sort of violates the integrity of their supply chain. And that's what enables this poisoning attack only works if someone upstream of you is able to manipulate the model weights that you're dealing with. So I think that's the sense in which I would consider it a supply chain attack.
Yeah, fantastic. Thank you. And thanks for the great question, Lawrence. Okay, so as a data scientist, myself and a lot of friends who are data scientists and machine learning engineers, when I hear things need to be secured, and we need to have security best practices and these types of things, I'm like, of course we do, but I'm also like, that's going to slow me down.
Yeah,
but you're telling me, sorry, you're telling me that I can secure the machine learning supply chain without sacrificing velocity.
Well, you can certainly secure it by sacrificing velocity, right? Yep. And so there's a famous quote in computer security, the only secure computer is one that's like powered off and locked in a basement that no one can access, right? And I think the same thing is true here, right? If you're willing to sacrifice all of the benefits of doing data science, you can just not do it and then you have perfect security. If you're willing to sacrifice by not collecting data about your users that maybe is insightful, but has some risk because maybe there's some privacy concerns. You can avoid these threats by not doing it. But that's, beyond a sacrifice of velocity, that's a sacrifice of even functionality. Okay, so can we get
salary there? For me?
Yes, absolutely, and no one wants that. And so
got to pay the rent.
Can we sacrifice not functionality but velocity? And we see this happen in sort of the most sensitive areas. So if you're doing data analysis, often, I have colleagues who work in the U.S. federal government, I'll pick on, and all of their training has to happen in an air-gapped environment with an approved, an audited list of dependencies, all at specific versions. So they basically get a distribution of software that includes NumPy at a particular version, maybe PyTorch at a particular version. Obviously, these versions are, at this point, years out of date. They can't install anything else. It runs on an air gap. It's a big pain because they have to sort of do some experimentation locally. Maybe they're not even allowed that. Maybe they're only allowed to SSH in through a jump host to this air-gapped environment, and it's the only place the data is allowed to live. And so I would say in a very real sense, they have a better software supply chain security posture than most data scientists do today, but at really, really great cost.
Yep.
And that's a really great cost in velocity. So I'm promising you magic at this point, right? I'm saying we can get all of these benefits and not have to have any of those slowdowns.
But as we know, what's the saying? I forgot. Any sufficiently advanced technology is indistinguishable from magic. So
yes,
we're now the Penn and Teller of supply chain security. In
the magic here, someone in the chat earlier used the word design, and you, I think Hugo, also used the word design, and I think that's exactly it. The magic is designing our tools and such that the average user doesn't have to care. And so I'll give you a great example of that. It's somewhere that we're not at today, but I would be super excited to see this happen in kind of the medium term. When you're writing a job or a flow in Metaflow, right? You sort of talk about, okay, there's a stage at which the data gets introduced, and then this step runs in this environment, and maybe I annotate something and it's running in my Kubernetes cluster. Maybe I annotate something and it's running in this cloud environment, and so on. And so that Metaflow job, as you're running it, actually knows exactly the provenance of the sort of output model, right? And it is possible in theory, and I'm a researcher, right? So I get to say something is possible in theory, and all the people who actually have to go implement these tools are gonna swear at me because it's a lot of work to get here. But it is possible in theory then for Metaflow, as it's running through each of these environments that's running one of your training steps, can sort of provide cryptographic signed statements that say I'm GCP, and I promise that I ran, this training job with this input, and this is my model, and these are the exact versions of things I used, and this is the output I got. And you can take a statement issued in a machine readable format that basically says, what did each computational environment do? You can have those computational environments sign those statements. So, for instance, AWS would produce one, and you would be able to verify it against some public information that Amazon publishes, and you would know it's not forgeable. And you would be pretty darn confident at the end of that process at saying this output definitely came from this Metaflow job, and I know where the constituent components of the Metaflow job lived. And that's something that you'd be able to verify on the consumer end. And again, we would want people to do that not by looking at these these computer readable statements themselves, but by sort of integrating that into the Metaflow tooling. And so that's one example of how this might work. And that's a ways off. But we have, and we don't even have anything totally like that for general application software at this point. Nothing that magic, but we're starting to get there. And so a great example of that is NPM, the JavaScript package repository. Got tired of attacks where someone had a beautiful repository on GitHub where they had all the branch protection turned on and, two-party review, and the code looked great and was publicly scrutinizable. And then some attacker downloaded their source and then changed the source that was on GitHub to some malware and then typed npm publish, and it went up on npm, and it didn't match sort of the public repository.
Right.
And this is only one type of attack. There are a number of other, archetypes of attack that look a little bit different. But this was happening enough that NPM got sick of it. And they said, well, what can we do about that? What we can do is we can say, we need a verifiable link between the source and the package that ultimately winds up on NPM. And so programming languages where that attack, they need to compromise the build service itself, which is a much higher lift than being an open source maintainer that nobody's ever looked at and suddenly changing what's in the package you're uploading.
Great. And I'm really happy you mentioned provenance, because that's something I do want to get into, particularly, even pre-rise of LLMs, communities like HuggingFace are places where we as data scientists would increasingly get models and use them in production settings. So thinking through provenance in these types of places, I'd love to get your thoughts on how we can reason through that type of thing. Before that, though, you did mention earlier that software engineers, but in particular data scientists and people in the machine learning space are often incredibly interested in bleeding edge technologies, right? So, for example, as I can't, maybe you cited PyTorch, but this is an example where a lot of people want the most recent version of PyTorch, right? And of course, there are examples where, some horror stories that we've all had for us who've used Databricks, but or such vendors, it can be really challenging to have access to the most cutting edge version. Well, even there've been challenges with having the most cutting edge version of Spark within Databricks, which is a massive loss of. But enough about the challenges of big vendors. Not only do we necessarily want cutting edge versions, sometimes we actually want versions of open source software that are on development branches on GitHub, right? So when data scientists and MLEs want all of these cutting edge, bleeding edge, almost over the edge technologies, but we also need to think about careful dependency management, how can we navigate this tension?
Yeah, that's a really great question. And I think the answer is somewhat complicated here. And here's one place where I won't promise magic. I don't think there's actually a free lunch here, because by opting to use sort of a development version off of a branch on GitHub instead of something maybe that's been, audited on PyPI or coming from a vendor that sort of is looking at all this stuff as it's coming in, you are now taking on the risk that someone with access to that GitHub repository, which it maybe receives less scrutiny than your vendor audited repository that you're pulling from. Anyone with access to that GitHub repository is now able to sort of push stuff to your environment that might be kind of nasty. And so I don't actually think there's a free lunch here, but we can be careful, right? You can always say, when I'm choosing not to use something via the blessed source, I should know why, and I should be able to take a quick look-see at that source and make sure that it at least isn't obviously doing something bad or malicious. And then once you do that, we're now relying on tooling to help us with a different goal that I think has nothing to do and everything to do with security, which is reproducibility, right? In ML space, we're very concerned often with reproducibility of our analyses. We want to make sure, I come from kind of the academic world, right? We really always want someone to be able to take our code, run it themselves, and get the same charts that are in our paper. But this is really nice for a bunch of reasons. It makes you more confident in the analysis. It lets you rerun it later as the data change, and so on. And so in order to get reproducibility, we really do need to do some accounting for what actually ran. And so what doesn't cut it is you're on your laptop and you pip install something, and then you pip install something else at some specific version, and you pip install a third thing from GitHub, and so on, and you don't have a list of what got installed from where and from why. and then you kind of lose that information to the universe as you publish your analysis. That's really not going to fly here. But fortunately, we're seeing a move towards more reproducibility here, where if you're running in kind of a Jupyter notebook, maybe you're running in an environment with a known stack that's sort of uniform across your organization. If you want to install something separate from that, that'll have to be made explicit in the notebook itself, and you can kind of capture that information there. And even better, there's sort of a move towards talking about dependencies declaratively. So rather than saying, I'm going to start with this kind of base environment that all my Jupyter notebooks run into, and I'm going to use the shell magic to apt install this library. And that kind of implicitly depends on what's the latest version of that library at that point in time, and so on. You can capture things. And so the new PyProject.toml format is a great example of this, where instead of saying, I have an environment and I'm going to imperatively add something to it, update something, replace something, instead of that, you're just saying, what do I want in my environment? And you hit one button that says, configure it thus, right? And once we've got that, and then we can now introduce a lock file that says, great, you requested, PyTorch. Here is the version of PyTorch I resolved. And even better, here's sort of the cryptographic hash of that version.
And just so I understand, in terms of specifying this declaratively, is that the same, like data scientists are accustomed to use requirements text files or something like that? Is that similar to?
Yeah. So requirements text files are, I would say, getting there. But what's really powerful is if I were to say to
where you specify the version as well.
Yeah,
sorry.
Exactly. And to say to you, you cannot install things by running pip install anymore. You must just add them to the list of things that are in the environment. And at first, this seems like kind of a hassle, but actually, once you get used to it, it doesn't feel like any more work. And in fact, it's often, I find, easier because I can just copy paste a list of stuff from iterations I've done before. And now, instead of having to remember to make sure that requirements.txt file is in sync with my environment, I won't make folks raise their hands, but I'm certainly guilty of having an environment, writing a requirements.txt, updating something and forgetting to commit it or forgetting to update that. If you sort of manage your environment in a way that doesn't allow deviation between what's installed and what's written down, you now can feel so much more confident in knowing what's installed. And so back to the original question, how do we deal with having this stuff on the bleeding edge? There will be risks, but at least here we can know what was installed when, and carrying through this theme of provenance, if we're generating sort of alongside our model some metadata about how it was produced, you can know that, okay, we find out that some version of PyTorch was backdoored. I can go through all of my outputs and check whether any of them are plausibly affected by keeping track of this information. And again, I don't want people to be keeping track of this information by doing it by hand, right? And I feel like that's, in some sense, what requirements.txt is, right? You have to remember to update that. Instead, I want the tooling to be really good about doing this for you. I think you're on mute, Hugo.
Great, thanks, Zach. I appreciate the nuances there. And something we're kind of implicitly talking around now, and I don't necessarily want to dive into this too deeply, but I think it's incredibly important when talking about dependency management, is the containerization story. And so, for example, as you're aware, and some of our listeners maybe, when writing machine learning workflows, perhaps you want to have a bunch of stuff running locally, then you want to send a bunch of, let's say LLM fine-tuning or hyperparameter optimization up to GPUs or cloud workstations. And you want to make sure that you have the same software and same versions running on both. Now, shameless self-promotion. But Metaflow, of course, affords this, for example, using an @Kubernetes or a GPU resources decorator, where you can run exactly the same code and add a single decorator to do this. This is actually, one of the things that I think is magical about Metaflow and allows data scientists kind of increase productivity here. But when doing that, a lot of the time, data scientists will specify how they want their Docker images configured, for example. And I know I'm leading the witness a bit here, but I am aware that you actually wrote a wonderful blog post about some of the concerns, security and otherwise, that can occur with Docker containerization in particular. So maybe you could tell us a bit about your views on containerization.
Yeah, absolutely. I'm glad you bring it up. And I think containerization is wonderful for this because it sort of is a very like strong attempt to try to capture everything about the environment that ran. There are a couple of issues with it, which is, sure, if I have a container and I pass around a big fat container with all my dependencies installed, maybe now I can reproduce an analysis that I did, but can I reproduce the container itself is actually somewhat of a tricky question. And so one of the things people do is they try to write their Docker files in such a manner that they are able to reproduce it later. And so this would look like, using sort of a long-term support version of Ubuntu or whatever the underlying operating system is, kind of using the packages at specific versions, doing what I was just talking about with, PyProject.toml, or Conda enables something very similar as well.
Yep.
And so using sort of declarative management there, but it's really easy for kind of like state that prevents reproducibility to sneak in. Because when you're building an image with a Docker file is basically just a shell script, right? You start from some base image, you run some shell commands, maybe you copy some files in from your source repository, and then that's your container image. And so I think that does do a really great job once you have that container image of keeping things reproducible, but it loses a lot of that metadata about, right? If you take one of these containers and you want to ask, there was a backdoor in I think PyTorch Triton a couple months back. That was sort of, someone compromised one of these repositories, and it was PyTorch from the official PyTorch distribution was shipping malware. They took it down very, very quickly. As far as I know, there wasn't anyone actually compromised due to this, but like, this is the sort of risk we're worried about. If we want to go back now and see, did I actually build any models using that? I would have to open the hatch basically of the container to kind of try to see what was running in there. And so I'm a strong advocate, and this is something that my company tends to agree with me on, for building container images differently. How differently? I would say there's a number of technologies you can use, but the key thing is to try to move to a more reproducible and declarative model. So instead of doing things like having a step that says, let me, curl this data set from the internet and bake this data set into my image, or, clone this Git repository at this version and so on and bake that into my image. Things that like go out and hit the network and depend on the state of the universe, which is constantly changing as much as I would like it not to. Those sneak into the Docker file. And so you can build container images in ways that prevent you from doing that. And again, this I think requires a shift in mindset. It's the sort of thing where the first time you go through it, you say, oh, when I had a Docker file, all I had to do was to run curl here, and boom, all my problems are solved. But I think there's a stage of enlightenment where you sort of appreciate the freedom that the discipline brings, right? And by forcing you into this mold for creating your container images, and there's a number of tools that do this, and I bet Hugo is linking to the blog post I wrote about it.
I have, yeah.
That mentions a few. If you're using some of these tools, they force you into this way of composing, container images that has a number of advantages. One is better metadata. One is reproducibility. even without holding onto the container image itself. Another factor is sort of size. Often text configuration telling you how to get the container image is much, much smaller than the container image itself. And so all of these things kind of together, I think, point to a way to improve our reproducibility, to improve the level of detail we have about what exact versions are running and where they come from, what data was running and where did it come from, or what data was provided as input and where did it come from, and to sort of lock that down in a way that's only implicit and not explicit, using more traditional methods of building containers.
Fantastic. And I just want to say there was so much gold in there, but when you said, and I'm going to try to quote you almost exactly, there's a stage of enlightenment you reach when you recognize the freedom that the discipline brings. I feel like you've just become my sensei in terms of software development. I feel that very strongly. Look, we actually have a series of great questions in the chat, which we're not going to get to all of them, unfortunately. So I'm going to post once again a link to our Slack. If you join us on Slack and go to the AMA guest channel, Zack and I will be there to answer these and any other questions afterwards, because we've got a couple more things that are really exciting to talk about. We did hint earlier that we were going to talk about model provenance and distribution. So the most top of mind examples are like HuggingFace and LLMs and these types of things currently, but there are lots more. So I just wondering to what extent model provenance and distribution are necessary to reasoning through machine learning security concerns.
Yeah, well, the simple answer to that is they are very necessary.
Yes, great. Okay, done.
Yeah, done. Keeping an eye on the time. I'll try to keep it quick, but this is something I could truly talk about for hours. Just this question. And so yeah, this is all about sort of the distribution step. Where did if you were handed your data by the people that were producing it, I don't know, maybe it's a biological data set on the results of some experiments, and you got handed a USB stick that has this data from the researcher you knew did the experiment. Like, life would be so much easier, but that's not what happens. We go through things like HuggingFace, where you have to distribute the data, and there's a number of sort of landmines here. One is Hugo mentioned earlier, the format pickle, which is so convenient to use to pass around data. It just has one problem, which is that it embeds all of the capabilities of the Python language into the data format. So you can craft a pickle file when loaded will do something like scan your local memory for things that look like credit card numbers and send them off to some server in some enemy country. Right. And so the pickle data format is extremely dangerous, and it's convenient, but I'm really, really hoping that that's
convenient, and it's also a standard, right?
Yeah. No, absolutely. But I'm hoping that we're going to see kind of a push from, and this has to come from the libraries themselves, things like pandas and NumPy, a push towards serialization in safer formats. And I don't have a horse in this race, but things like Parquet or Avro or there's a number of them are all just data formats that don't let you embed code are preferred. But if you must load a data that's published in the pickle format, it's much better to do that if you know where it comes from. And that's exactly this question of provenance. So the provenance applies to the raw data that's coming in that you're training on. Provenance applies to trained intermediate models. So if you want to do LLM fine tuning, you're going to need to start with an LLM. And where are you getting that from, right? And so how do you know that these are the right things is a really hard question. And it's one that I think repositories like HuggingFace are going to have to help answer. But again, the hope is that you would feel HuggingFace would do enough kind of on their side that the average user doesn't have to think about it at all. And you just know if you get something off of HuggingFace, it is what it says it is. And that's really the gold standard that we're going for.
So I think to drill a bit deeper down, if I want to safely build on external models, such as those from HuggingFace, what type of, I suppose, what you would call an ingredients list do the models need? And I know you've used the term software bill of materials to think about this type of thing. So
yeah, exactly. So there's two ways to do this. The sort of simple way to do this is to just say, hey, I think Hugo's a good guy and trustworthy. Anything he signs off.
Mistake number one.
Yeah, right. But anything he signs off on, I am willing to run and use as training data or use the model or so on. And I actually don't like this approach. So this is sort of the approach where I figure out who I trust, and then anything they sign off on, I sort of indiscriminately trust that. And this is kind of something you can do by just like if you have digital signatures, digitally signing your model weights or something like that. Much better is signing metadata about the data or the model weights or what have you. And the best kind of metadata has really complete information about what's inside and where it came from. So we're starting to see a number of competing standards here, and I don't know what's going to win, but I hope one clear winner does emerge over the next year or so. But standards for basically saying, hey, what's in this model? Where did it come from? Where did the data come from? What kind of consent did the users whose data this is give? Is an important question. What sort of license is the data distributed under? What sort of license is the model itself distributed under? How was the model trained? Where was the model trained? And so on. And so you can compile all of this information into a machine readable document. And people will use terms like AI BOM, which is artificial intelligence bill of materials, or ML BOM, machine learning bill of materials. And this is by analogy with a bill of materials that you would have to give to, for instance, the US government if you were selling them a fighter jet, right? You need to know where every nut and bolt came from, and every part needs to be traceable. Same thing for software, and same thing, we're starting to see this in software, same thing for ML models. And so I can't tell you today what that format is going to look like, but there's a number of groups, and if you ask me in Slack, I can point you to some references that are kind of working on this problem, and the standard is hopefully emerging.
Fantastic, thank you. We do have a question: doesn't Mr. Pickle sell sandwiches? Which I like a lot, and I don't know the answer to that. Having said that, we'll wrap up in a second, but Zach and I are both in New York City, in Brooklyn, actually, and I don't know if you've seen this, Zach, but there's a somewhat new bookstore on the Lower East Side on Orchard Street that sells pickles and books. They're a pickle bookstore, which you couldn't imagine happening anywhere other than the Lower East Side. And I just remembered, of course, Orchard Street is one of the main streets for the annual Pickle Festival on the Lower East Side. So yeah, there's a lot to be pickled, and a lot of conversations around pickling.
Yeah, but when you're getting your pickles from the Lower East Side, make sure to inquire about their provenance.
Exactly. Look, I've learned so much from you today. I really appreciate your time. What I'd like to know is, we have a lot of data scientists, MLEs, data analysts here, and data professionals who watch this, hopefully in future. For people who want to get started today, thinking a bit more about this, definitely go and check out Chainguard, of course. But how can people get started today?
Yeah, I think the answer to that is, while I would love to be in this world where nobody has to think about these questions, we're not there yet. And so you really do. And so the main advice I would give is just try to be mindful of what you're running and where it comes from, where the data you're using as input comes from, and try to trace that. And so I would get fired if I didn't do a little plug for some of what we provide. So Chainguard is a company that will provide you sort of Kubernetes base images that come pre-configured with some of the dependencies that you're going to need in order to run a machine learning workload. And so our base images have the benefit of kind of being really trimmed down and not having a lot of extraneous stuff, which has a benefit for performance. It's much faster to copy them around, but also a benefit for security, which is that if you don't have a library in your container image, you can't have a vulnerability in that library that then gets exploited. And so like that would be a great choice. Instead of just using, from, the Docker Hub Jupyter image, think about the container images that you're running. Same with your sort of software dependencies. Instead of just, blindly adding the PyTorch at head, think about whether you really need it. And then if you do, make sure you're pinning to that version, that it doesn't sort of get updated with under your nose without you knowing about it. And ideally, and this is a lot of work, but ideally, at least take a quick skim and make sure that there's no obvious code in there that looks like it's gonna mine some Bitcoins on your machines. So that was a long answer, and unfortunately,
that's a great answer, and it's a set of principles and heuristics for people to start thinking about, which I think is actually, as opposed to a checklist of what to do and what to not, ways of thinking are incredibly important.
I'll also plug, I think Metaflow as a framework does a really tremendous job of trying to really pin down some of these MLOps principles. And so my hope is that we're going to be able to collaborate in the future to start shipping some of these security features and I can't promise anything on Outerbounds' behalf, of course, but shipping some of these things in Metaflow so that they just come along for free when we're ready. And already I think there are huge reproducibility advantages to using Metaflow, and that gets you a big chunk of the way there.
Yeah. Well, what I can promise on Metaflow and Outerbounds' behalf is that if you watch this space, I'd be very surprised if you weren't excited. And I've linked to chainguard.dev in the chat as well. So please do check out Chainguard and what Zack and colleagues are up to, because it's super exciting stuff and aligns a lot with how we think about building ML software as well. We didn't make it to all the questions. But I would love if you joined us on Slack for the AMA, and very excited to see you there. I'd like to thank everyone for joining, and for those of you still around for joining us until the end. It was fantastic to have you here. And most of all, I'd love to thank Zack and Chainguard for joining today as well. So thank you, everyone.
My pleasure. Looking forward to chatting more with folks in Slack.
Absolutely. And